All right, so we're going to go ahead and get started with this. So the big thing that I want us to see with the problems is they're not, even if we have a formula, um, even if we have a formula to use, they're not always going to come up. They're not always going to be presented in the way that we expect. So as we're doing these types of problems, you're going to run into things that it's going to ask you or expect you to know where to find certain information and look certain information up. So on this problem, there's two issues with the problem. So for density, the three things that we're looking for density, we're either looking for density, mass, or volume. All right. So looking at this problem, we're given a volume there, and we're given a volume there. Do either of those volumes represent the volume of the object in this? No. So this is a displacement problem. So how do we find out the volume of the object? Okay. So volume is going to equal the new volume, 13.2, minus 8.1. And so when we do that calculation, what should we come up with, and how many, and what's the correct way to write it? All right. So our volume should be one decimal place because both of them only have one decimal place. And so our volume is 5.1 milliliters. Now, the other thing to look at this, and so on a test, they're not going to give you this table. But in your periodic table reference packet, they'll give you, there's a table just like that. I think it's on the second page of the periodic table reference packet. All right. So what's the other number that we're going to use in this one? 11.4, our density. How did we know to use the density of lead? It says a lead ball. All right, so I'm doing this intentionally because this is on test one. This was usually, a problem like this was one of the most missed problems. Students would get there, they just saw the volumes, they would subtract, they would get this number, and they would answer this number. All right, and they would think that's it. But they didn't read the rest of the question. The question is asking us, what is the mass of the lead ball? And so they weren't realizing they could look up the density. Look up the density, grams per milliliter. I think this one says grams per centimeter cube, but remember that a milliliter and a centimeter cube are the same thing. So I can interchange that unit. So now I'm trying to solve for mass. Mass is density times volume. So I'm going to take my 11.4 grams per milliliter times 5.1 milliliters. Notice that I have milliliters in my denominator, so that cancels and leaving this with only grams. So what is our answer? All right. So how many Sig Figs are we going to answer on this? So this is 2. This is 3. So I need 2 Sig Figs on my answer. So I have 58.14. So my mass, not today. My hand ain't going to cooperate. All right, my mass is 58 grams. All right. Questions on that one? I will tell you, I would expect something like this on the test. All right. If at the very least, it will give you, at the very least, it'll give you a volume, and you have to recognize to look up the density. You'll have to know to go to that periodic table reference packet. They're giving it to you as a resource to use on the test, as a tool to use on the test. So make sure you use the tools that they have. All right. So trying to wrap up chapter 2. It's really, this chapter is all about conversions and things like that, and being able to use the tools that you have. So here is another type of problem that might show up on a quiz or a test. And I'm going to get you to solve it, but I'll read through it just to start it. It says a sample of metal beads is added to an empty beaker with that empty beaker, and then it tells us the mass of that beaker is 70.55 grams. With the metal beads in it, it weighs 147.7 grams. The beads are poured into a graduated cylinder containing 35.62 milliliters of water, and the water rises to the 44.1 milliliter mark. And then it wants to know the density. So again, this time we're solving for density. So we want to know density. So that means that we should know the mass and the volume. So we should be able to determine the mass and the volume. How do I determine the mass? Okay, so what numbers am I using for the masses? 147.7. All right, so 147.7 and 70.55. What about those numbers tells us it's a mass? The grams. All right, so when we see grams, we should automatically associate that with a mass. When we see something like milliliters or centimeters cubes, we're going to associate that with a volume. If I saw grams per milliliter, I'm going to associate that with a density. So getting the mass, I'm going to do 147.7 minus 70.55. Now, notice my answer. My answer is only in one decimal place. And that's because addition subtraction rules puts it in one decimal place. All right, so I'm going to use the other two for volume. So I'm going to use 44.1 minus 35.62. And once again, notice my answer is only in one decimal place because my volumes, one of them was only measured to one decimal place. All right. Now, don't get hung up on that they're different units and we're dividing by different units. In this class, you can do that. We're going to create a compound unit of grams per milliliter. So now, how many, when we do our answer, how many Sig Figs is my answer going to have? 2. So what, when we do this calculation, what do we get? All right, so our final answer, 9.1 grams per milliliter, right? When you do it in the calculator, you get 9.08235, so and so. Continuing on. All right. But when we do this, our answer is 9.1. So the other area that I see students make mistake, especially on the DE test and all of that, is this one might be one that is going to ask you to enter in the number. If you enter in 8, while technically that's right, if you enter that in, the test is going to mark you wrong. All right. You have to be able to recognize that because of this calculation, that makes that 2 sig figs, and then your final answer can only be 2 sig figs because you multiply and divide then. And so even now, it might have given it to you if you wrote 9.0. It just depends on what type of problem is and how much variance they're given. All right. But in this one, because it's only 2 sig figs, the answer has to be 9.1. All right. And it's because that 8 rounds to 0 to 1. I know at least for this very first test, they are very, very, very tight on those kind of numbers. And I've maybe been a little bit looser on telling my students that in the past, and I want to make sure that my students aren't making those simple mistakes, that the mistakes that we're making are because it's something that maybe was just a concept we didn't get. This is something I don't want y'all to miss. All right. So let's look at active. I'm going to go through a few more of the problems in actives. It may be problems that you've had. It may be problems that you don't have yet. We're going to look at these, look at setting up and things like that. So I'm looking at number 25. So if you want to open up number 25 and do it along with us, you should have the exact same numbers on this one. All right. So looking at number 25, it says a popular car engine that is reported to have a volume of 4,320 centimeters cubed. What is the size in cubic inches? So last week on Friday, we started talking about how do we get, so we have in our reference packet, we have a conversion factor that says 1 inch is 2.54 centimeters. Now, I'm trying to go from centimeters cubed to inches cubed. Can I use that conversion factor as it is? All right, I have to cube it because right now those conversions are not cubed. So what I really have to look at is all right. So I have to get my units to the right unit. So I'm going to use 1 cubed cubic inches, 2.54 cubic inches. So I know that 1 cubed is 1. And then I can actually leave this like this, or I could do it in the calculator and find out that it's like 16.387 centimeters cubed. Huh? No, I looked right there and I knew that was the answer. I've done it enough that I know it. All right. So looking at the problem, are given. So I'm going to start here. 4320, and that's centimeters cubed. Now I can pull this in. I want to get rid of centimeters cubed. So, and I want to go to inches cubed. Now, notice it gives, there's a couple of different options this one gives you to get to the right answer. You could show the 1 cubed there, or you can show the 1 there. Both of those will work because 1 cubed is 1. So I probably, not there. For my inches, I'll probably put just the 1. Same thing for the centimeters cubed. I have 16.387. I also have 2.54 cubed. I can plug either one of them in. But just because I'm going to pretend like we already did the calculation, and I'll do it like that. Yeah. All right. Now, so the next thing I'm going to verify, does centimeters cubed cancel based off of what I set up? And then I'm going to put my answer box there. My answer should be in cubic inches. So you may have to scroll your screen down there, but you'll click the one right here. So sometimes, depending on if you're zoomed in or not, you can scroll. You should be able to scroll this screen up and down right here and get to it. All right, and I'm not going to put the answer in, but essentially you're just dividing by that. Now, before this one, it probably doesn't give you any other choice, but how many Sig Figs should our answer be in? 3, because 432 is only 3 Sig Figs. Remember, this one, since it was a known conversion factor, this one is exact number, so it doesn't affect our Sig Figs. All right. So going through, if you're, you can go ahead and look at number 28. Number 28, we might have to do a little bit more for. 28 says a liquid in the lab has a density of 1.17 grams per centimeter cubed. It says, what is the volume? 28. What is the volume in liters of 3.02 kilograms? So first thing that I'm going to notice is this is a density. All right. My density is in grams per centimeters cubed. The volume they want me to get to is in liters, and the given is in kilograms. So I'm starting with my given 3.02 kilograms, but I got to find some way of getting from kilograms all the way to liters. So is there something, so if I'm going to use my density as a conversion factor, because that density right here says that I have 1.17 grams for every 1 centimeter cubed. Can I use that? Can I use that conversion factor right there? Can I use density yet? Okay, what's the first thing we have to do? We need to get from kilograms to grams. All right, and so my conversion factor on that is I know that kilograms is 10 to the third. I know that grams is 10 to the 0. So that means that kilograms is my larger. So for every 1 kilogram, I have 10 to the third grams, or 1,000 grams. All right. So my first conversion factor, I want to get rid of kilograms, put it on the bottom, want to go to grams. So Now, in this case, they had 10 to the third. If they didn't have 10 to the third as an option, they probably would have had 1,000 as an option. All right. So that allows me to get rid of kilograms. So am I finished? Am I to where I want to be yet? No. So what's the next step I can do? I can convert using the density because I can go from grams to volume here, right? So I can go from mass to volume. So I can go from grams to centimeters cubed. So, and I want to get rid of grams and I want to go centimeters cubed. Now, technically, I'm going to show you the long way to put this in here, but technically I could have skipped a step. I could call that milliliters right now if I wanted to, because centimeters cubed and milliliters are the same thing. But I'm going to go ahead and show it that 1 milliliter is 1 centimeter cubed. And then now, going from milliliters, going from centimeters to milliliters, and now I need to get to liters. So remember that milliliters is 10 to the negative 3, liters is 10 to the 0, liters is larger, so it's 1 liter, 10 to the third milliliters. So my last box that I'm going to put here is 1 liter, it's 10 to the third milliliters. It's going to be blank liters. All right. A couple of things, data entry in your calculator. I want you to notice something. Notice that I'm multiplying by 10 to the third here and dividing by 10 to the third here. So mathematically that cancels out. So really and truthfully in the calculator, I'm going to do 3.02 divided by 1.17, and I'm going to get my answer. But I did all of this to make sure that I'm getting rid of the right units and that I'm putting them in the right way. All right, questions on that one? And I mean, if you're really wanting to see what I was just saying about that 10 to the third cancels, you can plug it in both ways and see. If you did 3.02 divided by 1.17, or if you did 3.02 times 1,000 divided by 1.17 divided by 1,000, is going to give you the same answer. All right. And then question 30. This one's one that it doesn't give you the little tool to set it up to see that you're canceling it. It just gives you some information, and we have to set it up for ourselves. So question 30 says, how many miles can you drive if your car gets 28.2 miles per gallon and you have 12 gallons of gas? So which, in number 30, which of these is our given? Which of these is our starting point and which of these is our conversion factor? What's different about this unit versus this unit?
Miles per gallon.
So miles per gallon, is a compound unit. So if it's a compound unit, we can use it as a conversion factor, whereas this is just a singular unit. So I'm going to start off here. All right. And then I have this that's a conversion factor. So for every 1 gallon, I can go miles. So I get rid of gallons. Now, based on the information given, how many sig figs is my answer going to be? 1, 2, 3, 4. 1, 2, 3, 4. All of those count. There's a decimal place there, so answer has to be in. Sometimes active gives you a little bit of leeway on that, and it'll just tell you that the sig figs were incorrect, but it gives you the correct answer. Sometimes it's going to mark it wrong and tell you that it's because of sig figs. So just be aware of those. All right. So what I'm going to let you do now is I'm going to let you have some time. If you're not finished the active stuff, I'm going to give you some time to work on it in class. You can ask questions of your neighbors. You can ask questions of me. I'm going to – so tomorrow we're going to be starting into chapter 3. The homework, the active chem stays open till like 11:59 or so tomorrow evening. So I'm leaving it open for you to do, but I want to give time for individuals to have questions in class and me to work one-on-one with you with this. If I can get my scheduling right, I like to do like Fridays as days to work on active problems so that you can ask questions. But there's usually going to be at least one day a week that we devote 30 minutes or more just to working in active. So just be aware of that.